Sea level rise is, of course, one of the key impacts of global warming and also the glacial deglacial periods. Sorry, this figure is a bit fuzzy here. Because the sea level rise determines the coastal living spaces, habitats, groundwater invasion, salinization, and of course how much storm surge and inundation happens when cyclones and storms come in. With global warming, we are changing the cyclones and storms, as we will see later, and sea level is rising, and we are going to create multiple impacts, and coastal population is continuously increasing and is expected to continue to increase. The basic ideas here are that you have multiple components to the sea level rise. Let me just adjust this so that it's not so fuzzy. I think that makes it a bit better, I hope. Okay, maybe not. Okay, so when you build ice sheets, remember several kilometer thick ice sheets load up the continent, so much water, so heavy, 1,000 kilograms per meter cube, that tends to push the continent down, and if you push the continent down here, the crust would rise ahead of it or around it. So you can see, because the lithosphere is flexible, the flexure, I don't know how it's pronounced. I should know. It's pushed down here, so it's going to be raised up on the other side, and you're going to have convergence into these regions and then divergence below. So you can see the viscous flow in the mantle is going to be introduced. So relatively speaking, if you are here, sea level would go down, because let's say there is an ocean here. If continent is pushed up, sea level is going to relatively go down, and when the glacier is removed, then the lithosphere recovers, mantle responds, and then these regions which were raised up are going to go down, and this region that was pushed up is going to come up. So again, there is going to be relative sea level. For example, in the last ice age, glaciers were built up, let's say, on North America down to New York, and that pushed that continent, that part of the plate down, and the plate ahead of it all the way down to the Gulf of Mexico was pushed up. Since the glaciers melted away, those regions are rising up. So in Maine, relatively sea level would be dropping compared to the last ice age, because you are raising the continent, as opposed to New Orleans, let's say, where the continent is subsiding because it was raised up, so relatively sea level is going up. Now on top of that, you add the ocean warming and the expansion, storms, loss of coastal vegetation and so on as well, add up to all kinds of complications. So this local adjustment of the continent lithosphere is called isostatic adjustment, but the water that you lock up in glaciers, that is being taken from the ocean and is going to be released back to the ocean. So that creates sea level rise across the globe. That's called eustatic sea level rise. So you have isostatic and eustatic. There is also glaciostatic and other tectonostatic, other details. But the other component is thermosteric, where you can look at these multiple components together. Terrestrial water storage, extraction of groundwater, building of reservoirs, changes in runoff and seepage into the aquifer are all going to affect the water balance at some stage, as well as the continental movement. So subsidence in the river delta region, land movements and tectonic displacements will happen because of natural processes, as well as holding up water in large quantities and pushing down the plate, or releasing less sediments compared to the natural flow, and so on and so forth. For example, the Himalayas are one of the largest sediment loads in the rivers across the world, because Himalayas are still growing and it's a relatively fresh mountain in geologic time scales. Monsoon got set up after the Himalayas rose, let's say 30 to 10 million years ago. So a lot of the sediment that comes into the Bay of Bengal is going to push down and create subsidence and relative sea level rise. So the northwestern Bay of Bengal is one of the hotspots for sea level rise, for example. Surface and deep ocean circulation changes and storm surges will be affected by sea level change as well, and they will contribute to sea level. We'll see a pattern in a minute. As the ocean warms, water expands. That's the thermosteric change. You would expect that, and that contribution is quite significant. I think it's almost 40% if I remember right. Exchange of water stored on land by glaciers and ice sheets with the ocean water. That's the eustatic change that we just mentioned. So here is ocean heat content in 2018 compared to 1955 to 2006 baseline. Orange and blue areas show where the upper 700 meters of the global ocean gained or lost up to 3 gigajoules, 10 to the 9 joules of heat energy per square meter. Massive amounts compared to the long-term average. Warming of the ocean water is raising global sea levels because water expands when it warms. So global mean sea level has obviously consequences in terms of thinking about global warming and its impacts, but obviously local patterns matter a lot. So if you're living here and sea level is actually decreasing versus the neighborhood where it's increasing, etc., are critical in terms of climate adaptation, mitigation strategies, protecting against storm surges, and so on and so forth, or protecting the coastal populations, etc. So here is the global mean sea level projected for various scenarios again. RCP 8.5, so there is a range based on multiple models and uncertainties. RCP 2.6 would give us global mean sea level of about 40 centimeters. That's with respect to the baseline as well of somewhere. Okay, so these are the ranges for 2081 to 2000, and we have to plan for these, but there are details in terms of how much you can actually plan for. It may just be constrained by the finances rather than the projections of sea level. So even if there is a projection of 1 meter sea level rise for Mumbai may only be able to afford protecting against 50 centimeters of sea level rise, for example, financially speaking. Okay, so this is the recent sea level rise in the historic period going from the 1880s to the present. So there is a global sea level change of 20 centimeters or so. This is the satellite period, and there is some evidence that sea level rise is accelerating in the global mean and in some places, as we saw here. So you can see the hotspots here in terms of heat content increase, which would translate to sea level rise as well. So let me maybe stop here and come back in the next podcast about changes in glaciers and sea ice. Of course, we can just look at mass changes here and sea level contributions since we are on this topic. So this is a nice figure from this Copernicus paper that shows the contributions from Antarctic sea ice. So Antarctica has, of course, massive land glaciers, but it also has lots of sea ice. Arctic sea ice, ice shelf calving, so the glaciers that flow onto the ocean and get broken off. Ice shelf thinning, so the ocean warming from below can begin to erode the ice shelves. Basically, ice shelves are glaciers flowing onto the water, as we will see later. Grounded ice over Antarctica, Greenland glaciers are also contributing massive amounts to the total sea level rise here. So the total is in the range of 30 to 35 millimeters, and the mass change, so this is only from 1995 to 2015, so we have to watch for the acceleration. So you can see that the total sea level rise is accelerating, which is what I mentioned before, and the change in mass in gigatons is accelerating as well, and it is pretty large. Okay, so we'll come back and look at more specifics about the losses that are happening or are projected to happen over the Arctic sea ice region, Greenland glaciers, and Antarctic glaciers. We will see some contrasts between the Antarctic and North Atlantic regions, because Antarctic again is a circumpolar ocean as opposed to the northern hemisphere, where you don't have a circumpolar oceans, right? The Arctic is kind of a little sea that is open, but there you have sea ice that can get very thick because it is semi-enclosed, fresh, relatively fresh ocean because of all the runoff from the continents that surround the Arctic Ocean. Okay,